the Gabriel say welcome. Before.
Okay, welcome to everybody to this virtual workshop meeting session of the workshop, let's say. Every presentation will have 20-25 minutes. Then we have at least one commenter for each presentation, and then you can ask questions. So I ask you not to interrupt the people when it's presenting. So, and Emiliano will control the time. Okay?
Okay.
So we start with Marcelo Álvez and then the list. Nico.
Well, thank you. Thanks, Gabriel. Thanks for the organizer. I'm happy to be here, and let me see if I could share my screen. Yes, yeah. Here. Well, I will talk about this word, progressive contacts, and approach, joining with Emiliano and Gabriel. As usual, the content of the presentation is my responsibility, and it does not represent neither the Central Bank of Uruguay nor the Universidad de la República. The big picture of the paper, we do an experiment using a laboratory economy simulated by an agent-based model. And what we do is let the time runs in an economy with a proportional income tax and observe what happened after 50 periods with the economic growth. Then we restart the economy and make a change in the income tax. We impose a progressive income tax and see what happened with the economic growth after this change. And we do that 5 times with different thresholds for this progressive income tax. We impose a first part of the income that is exempt from the tax, and the rest of the income pay a positive tax rate. What we can see with this change is the trade-off between consumption and saving, because the change in the income tax implies a transfer from the household with the highest propensity to save and the lowest propensity to consume to the household with the highest propensity to consume and the lowest propensity to save. So it could happen that the area demand increase because of the higher consumption, or in the opposite way, it would happen that the investment decrease because the lower saving in the economy, and a priori we don't know what happened with this change in the taxation. But what we observe, our main result, is that there are no significant difference in economic growth in the presence of one tax regime and the other. And as a second result, we saw lower levels of inequality are reached when the sharehold increase, but difference in inequality between scenarios are smaller once low-income households are fully exempt for the tax. We see that when we change the threshold of the progressive income tax. Our work is in the literature about inequality, which could be seen as a problem by itself because their negative relation with other variables like health, consumption, household indebtedness, growth, or financial stability. In particular, the relationship between growth and inequality is not clear if it's positive, negative, or if it depends on the growth stage. It could be that in a further stage of growth, this relationship could be positive because growth is based on the accumulation of physical capital, and in later stage, it could become negative because growth could be based on the human capital accumulation. And there is a third variable that could interact in this relationship, which is redistribution, and in particular, Alesina Roderick and Persson and Tavellini states that redistribution could be negative correlated with growth, and we want to see with this experiment that if a particular redistribution policy could affect the economic growth. The methodology that we use is the complex system approach. Here in the workshop, you know about that. Let me just give a big idea. Complex systems are characterized by the emergency property, which means that there are properties of the system that are couldn't be recognized by the individual analysis of the part of the system, and they emerge from the multiple interactions between the multiple agents of the system, and this system also characterized by the non-linearity relationships and positive and negative feedbacks which occur in the system. This is a result that could be in the same sense of the action, and this is a positive feedback. And the result of an action could be in the opposite sense, and is a negative feedback. And they also characterized by the presence of thresholds and breakpoints, and this implies that the dynamic analysis of this system is important. In the complex system approach, we use an age-based model, and the main difference between this kind of model and the traditional approach is that we don't assume rationality. Agents have limited rationality. There is a learning process and adaptation. They don't optimize an objective function. They act through heuristics, and the information is not perfect and symmetric. There is local and asymmetric information. This is a graph of the transaction that happen in the model. And what I want to emphasize here is the process of innovation. This is a Schumpeterian model, and the growth is based on the technological change, which happened with innovation inside the capital firms. They could develop a new variety of capital goods with higher productivity, or they could imitate a capital good that is produced by a competitor. I also want to emphasize that there is 4 different type of households with different human capital, but the human capital remain fixed for each household, so there is no mobility between this class of households, and in particular managers are who earn the highest income and government the lowest. So these are the two type of households that are more affected with the change in the income tax. And the decision of household between consumption and saving. If they want to save, they deposit their savings in banks, and banks are who lend money to firms to do the investment or to hold the production. So indirectly, by the banks is a connection between savings and investment. This model is based in previous work of Carl et al., Dos et al., Cayenne et al., and so on. Let me move to the experiment that we do. We have an income tax that divide the income into parts. From 0 to C, there is a tax rate tau 1, which is equal to 0. So there is a first part of the income that is exempt for paying the tax, and the rest of the income from C plus 1 to the end pay a positive tax rate of tau 2. In the baseline scenario with a proportional income tax, C is equal to 0, so all the income pay a positive rate tau 2. We try 5 different levels of the sharehold, and in particular the results that I will show is with the extremist case of the highest sharehold, where we expect to see the more important change between the baseline scenario and the alternative one. Here you can see the GDP. In each line reflects a particular simulation. We did 100 simulation per scenario, and in blue you can see the baseline scenario, and in green the alternative one, and the dark continue lines are the median of the 100 simulation for each moment of time, and the dotted line are the 5th and the 95th percentage of these simulations. And what we expect to see here is that between the dotted lines, which is a kind of 90% interval confidence, we expect to see that these two areas shows separated, one up and the other down. But what we see is that these two regions overlap each other, so we couldn't affirm that there is a significant difference between growth in each scenario. So this is our main result, that there is no significant differences in the economic growth in each or in the other scenario. The dynamic that the economic followed is a first stage with high income, then a stagnation period, and then a third stage with the economic growth resumes. I will talk about this in a couple of slides. These are the main results. of each of the scenarios. You can check this in the paper. I hurry up a bit. These are other relevant variables of the economy. If you see consumption, it follows a similar path of what see about growth, and accordingly, unemployment start with low level and then increase in the stagnation period, and then go down slowly. And the graph that I want to show is this of the productivity. We start the simulations with homogeneity between among firms and households. Are all of the firms produce with the same technology, with the same price, pay the same wages at the start of the simulation, and when the times runs, it start to show difference between firms, and productivity start to increase little by little. And there is a moment around period 20 where the increase in productivity is sustained for the rest of the simulation. This is when the growth resumes for the economy. This time of stagnation occurs because there is needed to 3, 4, 5 periods for an innovation that is developed in the capital firm to translate to the production process and increase the productivity of the whole economy. I will move to the result of inequality, and here in the right side you can see the Gini index for each of the scenarios. The blue one is the baseline scenario with the proportional income tax, and when we increase the sharehold, we see a reduction in inequality. And this is what I say that at the beginning of the presentation. When we increase this threshold, we see lowest level of inequality, but once the sharehold imply that all the income of the low income households is exempt, increases in the sharehold don't imply a big change in inequality. And if on the left hand side, if we see the Gini index before taxes, we see that is pretty similar for all the scenarios. So the difference in inequality owing to the presence of the progressive income tax. Sorry. Just to say the final remarks of our work, in line with Ostri et al., there is no evidence of a deterioration in economic growth due to the replacement of the proportional income tax with a progressive one. In line with Piketty science, we see that changes in tax policy can affect inequality, and gains in terms of reducing inequality decrease once the shareholder value reach the income level of low-income households, and they are totally exempt. So we see that neither of these both effects that I talked at the beginning in the trade-off of consumption and saving prevails and causes a difference in economic growth. Our work has limitations. The validity of the result is limited to the probability space that is explored. You can see the sensibility analysis in the paper. Simulations length, maybe if we run longer periods of, of, of time simulations, we can see other emergent properties, but we don't know. And no alternatives are contemplated for public spending and other tax regimes. It could be interesting to explore these changes. Effects of investment decision in human capital are not captured, and is a main issue in this topic, and it's in our agenda. And there are no saving instrument options for households. This is also an interesting change that we want to explore. Our upcoming research is in line with these limitations. We want to explore a tax design that discriminates between middle and high income households. We want to incorporate investment decision in human capital. This is a main issue. We want to carry out the experiment in a different economic context, maybe more related with emerging countries with higher unemployment and higher inflation. We want to incorporate public spending tools and also investment alternatives for households. Thank you very much for your attention, and I open the floor to questions and comments. Thank you.
Thank you, Marcelo. Could you share the screen, please?
Yes. Yeah.
Okay. Well, thank you for your paper. Okay, this is, I have some comments from me and Cynthia Martinez, who work in finance and public. To sum up a little the paper, through a nation-based stock flow consistent model, the author analyzed the differences in income growth when a progressive income tax is established instead of a proportional one. They built two economies, one of them with proportional taxes, the other with progressive one. I will focus my comments in the inequality that the author had the hypothesis that the inequality will be reduced with a progressive schema, but there are no significant difference in income in economic performance in the presence of one tax scheme or the other, and the design, which only distinguishes two sections of income, is not able to reduce the inequality generated through the income distribution. Some of my questions are in the upcoming research that the author Marcelo talked in the minute. I have another questions. The questions are focused in the taxes. The author defined progressive tax as those that to have an aliquot greater or than or equal to average rate. But the average rate is a proportional tax. I think there is some ambiguity in this definition. Even if the evidence or conclusions are not conclusive, it is possible to include the impact over incentive when taxes change. For example, the functional relationship between taxes and the incentive to reinvestment from people. It is possible to include some question related to Laffer curve. For this, I think it is necessary to relax the assumption of a constant public recovery. And if a scheme of taxation change, the connection between nations will be the same. I think maybe there is some changes here to modelize. And that's all. Thank you.
Thank you, Silvia. I don't know if I respond, or maybe you want to read the question of the public.
No, please, please, you can respond to this, and then we open to more questions.
Perfect. Related to the progressive versus proportional taxation, yes, we have a proportional average rate for the baseline scenario with a proportional income tax. But when we introduce the change with a part of the wage exempt for the taxation, we have a different average rate when you change your income, because when the first part, the same part of the income is a fixed amount. So when you increase your income, you are changing your average tax rate. So in this sense, we define the progressive income taxation. And related to incentives, yes, we want to explore changes on that sense, introducing other alternatives that could reflect these changes in incentives. We don't give the household different alternatives for their savings, and this is one thing that we want to change in further works. And the last is about the fixed government sorry, what was the last point? The fixed public revenues or something like that.
If the question was if the schema of taxation changed, if the connection between nations will be the same, I think that maybe there is some changes to introduce when the scheme change.
Yes, again, we start from the simplest way that we took from the literature, and we want to slowly introduce changes to see what happened with each new change. In this step of the work, we want to see what happened with this change in the taxation way, with a first tranche of income exempt and the rest which pay a positive rate. This is the change that we are seeing in this work, sorry, and we want to explore further changes in the future.
Thank you very much,
Silvia.
We had a couple of questions from the chat. The first one was concerning the GDP results. What percent of the time will the alternative be higher than base? I don't know if you want all the questions, or you may answer one by one, Marcelo.
As you want. Referring to this question, our result is that we couldn't say that the growth in GDP is higher in one scenario to the other, because this happens if you compare one particular simulation which other, and we use a central measure, which is the median, and this 90% interval of confidence to compare one scenario with the other, and in this comparison there is no difference between the shaping in one scenario and in the other.
Yes, I agree with you on that. What I'm suggesting is that you could have done more. You've taken there a frequentist approach to it, which may be acceptable in the journals you want to publish in, but in so doing, you may actually be missing the chance to say, well, actually, we could say with some probability that the alternative is better than the base. Yeah, maybe if you were taking a Bayesian approach to it, you could say a bit more than you did. But yeah, but what you've done, I agree, is accepted in a lot of journals.
It's an interesting point. We could try to explore more in the comparison. Maybe we can chat later if you want to explore a different ways of make the comparison. Thank you.
Thank you, Christopher. Now, Felix asked about how is the initial distribution of wealth, and if the results could be affected about that. Well, I don't know if you want to ask it or.
Yes, in the initial distribution of wealth, we follow the literature, and in this particular case, there is a 30% of wage earned by the manager, which are the rich people there. Then 60%, which is from the middle income households, and the last 30% is for the poor, which represents the 60% of the population. 60% of the population and 30% of the wealth.
Okay. Bueno, El asked about what tools were used for modeling and simulation.
We use R software, and the program that we write for this work.
Well, I think the last point was about the Laffer curve effect. Okay. And Daniela, can I ask a brief question? Yes, of course, Daniel.
A little bit to Silvia's comment, and has to do with the Laffer curve, because I wonder, there must be some critical parameters lying around, some essential parameters, and probably, for example, the elasticity of investment relative to the post-tax rate of return or something like that. I have the impression that intuitively that may be one of the crucial parameters. And I think it would be interesting if you do some sensitivity on these apparently relevant parameters to see in what range of economy, so to speak, you may have some result or another. I think that would help in understanding, on the other hand, how the model works. Okay.
Thank you, Daniel. Yes, it's an important parameter to see. we took from the literature that the investment decision depends on the profit of the firm, but don't see the post-transaction return for the managers, which are the parameters that you are referring, I think, and is relevant, is an important one. Thank you.
Well, okay, and the last question from Felix Rioli. Felix, you want to ask something? Felix?
Sorry. Emiliano?
Yes.
Hello?
Yes, we hear you.
Sorry. Yes, my internet is very bad. I wanted to follow on the first question, the initial distribution of wealth. And the question was if different distributions were going to affect the results. If you type different distributions or just one initial, that I don't know if you could hear.
Yes. Again, we took the initial distribution of wealth from the literature. We run this experiment with parameters that are thought for an European economy, and is in our agenda to modify these parameters to reflect an economy more similar to an emerging country. And in this particular point, yes, we didn't do the sensibility analysis for the initial distribution of wealth, which we expect that this initial distribution could change the results, but in some sense, if maybe it could change for not confirming the diminishing of growth because of the progressive income tax, because it would be the case. With this initial distribution, we expect to see that as a lower row when we introduce the tax sanction, because the mechanism that could operate is that there is no enough saving to support the increase in productivity for the research and development activity, and this is not occurring in our experiment. But yes, it's a sensibility analysis that we have to do in this work, and is not did yet. Thank you, Felix.
I think that there was also another question regarding the Laffer curve on the continuous growth of taxation.
Hello. I'm sorry, but I think we are in time for the second presentation, Marcelo. So you can continue with Felix in other forms.
Perfect. No
Sorry.
problem.
Sorry.
Thank you very much for the
thank you, Marcelo, for the presentation. And now we have Marta Gabriel Alatriste. I think he's there. Emiliano, could you share the Emiliano is not here. Hello, Marta Gabriela.
Yeah.
Acá
yes,
estoy.
I'm here.
Here I am. Should I share my screen now?
Yes, yes, you can
Okay.
share your screen.
Okay, here it goes. Can you see it? Is it okay?
No, we can see it.
No, not yet.
Not yet. Ay, ay, ay. Pizarra. Okay, hold on. No sé qué pasa. Permítanme. No sé por qué no puedo. Can you see it now?
No,
No.
Emiliano, no.
no.
Maybe I need some assistance. Now?
Ahí está.
Okay.
Perfect.
Okay.
Perfect. I'm so sorry for this. So
No
hello
problem.
to everybody. My name is Marta Alatriste. Thank you for the organizers for the invitation. I'm gonna start now. So I'm gonna present a research work that I did with Martin Puchet here at Mexico City Universidad. This is about impact of sectoral shocks in North American production network. In particular, I will let you know, it's how a shock on manufacturing industries would affect the economies within the region. So first, let me talk to you about our motivation for this work. So, well, first, we all know economies are highly interconnected systems. So we know that a shock on one part of the economy will have effects on the whole system. And when we talk about production networks in regions, this effect may also affect other countries. So we are particularly interested in this type of setting because recently Mexico just signed a renegotiation of the trade agreement with Canada and the US. And in this new trade agreement, we wanted to see what would happen for Mexico in particular if the manufacturing industry is somehow shocked. So we have this idea that free trade agreements would improve the competitivity of the region in general and will enable the supply chains to form and to improve performance, and this exchange of goods, services, and also of human skilled workers, etc., would beneficiate everyone within the free trade agreement, but this may not be the case. So for Mexico, we've seen since 1994, that was the first free trade agreement we had with Canada and the US, the industry in Mexico has not benefited as much as it could from this export-driven model for growth. So this is part of our motivation. And also in this new renegotiation of the new trade agreement, Mexico stated explicitly that one of its priorities was to promote the participation of Mexican industries in value chains. So how can we do this? How can we actually see if this trade agreement would enable this global value chain, or at least would spread positive shocks in the production network reaching the Mexican industries? So we focus on this last point. So we have one main objectives that I could put in 2 points. The first one was actually to evaluate if this trade agreement would benefit all the countries that participate. So it would benefit Mexico, Canada, and the US in a similar way. And also take advantage of some techniques of computational simulations and some ideas from complexity science to do this. Okay, so before going to data, I just want to say we have the idea that a shock is something exogenous to the system that is changing the way this manufacturing industry is using inputs to produce. So it's not necessarily a negative shock, it's just a shock. No, it's just something that is perturbating the system from its current state. And we want to see how many sectors besides this manufacturing industry are affected by the shock, and if this is different for every country. So for that, we use input-output tables from the WIOT, which is the World Input-Output Database. This is public and anyone could access this database. And this has data for Canada, Mexico, the US, and for the NAFTA region as a whole system. It classifies the economic system in 35 sectors or industries that we use sectors or industries interchangeably. And the data, like the latest point in time is for the year 2013. And I don't know the particular reason why they haven't updated the database, but at least it will give us a sense of how the system was before this renegotiation, because the renegotiation of the trade agreement between these countries was signed in 2017. So at least we could see how was the system before they signed this new trade agreement. So now I go to the methods we followed. So we have 2 points. First, how we construct the networks, the production networks, and then how we apply a diffusion model to see how this shock on manufacturing would affect the economies. The methods we use are to study the effects of a shock hitting the manufacturing industry in particular, although it could be extended to analyze a shock on any industry of the economy. As I said, the shocks that we apply are the type of shocks that change the flow of inputs, both the demand and the supply of this industry. And the whole model was grown with Python, and we used only 3 libraries to do so. So you can find it in the text also. And well, if you are interested, you can access the code in the Open Science Framework project. So the production or the productive network, which is the base in which we apply the network diffusion model, comes from the intermediate demands table. In the output table, we have 3 components, let's say 2 components. First, the intermediate demands, that are this is a square matrix where we have the flows of inputs from one sector to another. So rows are sectors, columns are sectors or industries, and each cell is telling you how much money an industry is paying another one to buy inputs. So we use this intermediate demands table. The other component we have is the final demand table, or final demand vector actually. We left that aside, and that would be some exogenous data to the model. So this intermediate demands table becomes the weighted adjacency matrix of the production network, and we'll have entries with some weight different from 0 if two industries are connected through the supply or demand of inputs. And it will have 0 otherwise. Now to, let's say, the baseline model for production following the input-output model is the simplest one. And we just have that X is just production, and it's equal to these intermediate demands plus the final demand. So we can actually compute production from the input-output table directly. And we solve for X, no? Just to have the vector of production. Why is it important to have vector of production? Because actually that's where we're gonna compute the effects. So in the following slides, I will show you that we count as an effect on other industries if this production is disturbed, is changed. So here is just a brief description of the network. So we have the intermediate demands table at the left, and we have the network at the right. As I said, each row is a sector, each cell is a weighted directed link, and we have self loops. There's no problem for that. It is only capturing that an industry is supplying itself for production. And at this aggregation of the economy, which is 35 industries, it's common to observe their self loops. So now that we have the networks, and we do this for each economy. So we do this for Mexico, for Canada, for the US, and for the NAFTA region. And now that we have the networks, we apply the spreading of a shock on technology. So we apply actually a model that was published before in Physical Review E in 2014. And this corresponds to model 3 of that article. You will find the whole reference in the paper. And it actually introduces a modification of the input-output model when we actually consider time. So we have this updating in the system. So first, a shock hits the manufacturing industry and changes the flow of inputs with respect to other industries. So we have that these intermediate demands that we call them C are changed. So this changes the intermediate demands table, and at the same time, this will change the direct coefficients, which is this A's, AI, AJ. Now that we modify this structure, because this is at the same time changing the structure of the network, we recompute production with the input-output model version that we introduced with time. And then, now that we did that, we observe if this change has means an effect on other industries. So the rule that we follow to count if the shock is spreading to other sectors is this equation 4 at the bottom of the slide. In the paper, you will find the whole development of the equations. This is just the last step. So we have that if the change in both the supply and the demand of inputs of the manufacturing industry with its direct neighbors is larger than some proportion of its production, here we have the C and the X, then the shock will spread. So if you see, we have two parameters of the model. We have the F, which is the size of the shock. So the flow of the demands and supplies of inputs decrease by F. And we also have another parameter, which is C. These are the same for every sector. We do not change that. It's just the same for every sector. But as you can see, since we multiply it F by the flows of inputs and C by the production of each sector, then the amounts will be different, although the parameters itself are the same. So we have two parameters, F and C. And then we have a spread. Why is a spread? Because at the first wave, the shock spreads to the neighbors, direct neighbors of the manufacturing industry. But then the waves can continue. So now we can apply this equation for the neighbors of the neighbors of the manufacturing industry, and the neighbors of the neighbors of the neighbors, and so on, until the whole economy has been evaluated. So we have that the largest effect that this spreading shock could have is to reach the entire economy. So that would be 35 sectors affected. So to observe the result, first we apply the model in the combination of parameters for different values of F and C. And then we observe how many sectors are affected by this shock on the manufacturing industry, and what's the composition of these sectors in each wave, let's say. So because the order of the sectors being affected would not be the same. So here I just put some particular points of the results. The whole table of results are found in the paper. Let me just say that one of the main results is that the waves for the US are much longer than the waves for Mexico. So when manufacturing industry is shocked in the US production networks, we find that the waves are approximately 30 sectors affected, and for Mexico are around 10. So the effect of shock in the manufacturing sectors will be much greater than in the US. Results for the NAFTA region as a whole are very similar to the US. So the NAFTA region network is behaving as the US, which is its main force, let's say. And Canada, it's always in between Mexico and the US in both cases, and the number of sectors affected. Other important result is not only the waves, but the composition of the waves. So let me say that since the US, the waves are really long, we have almost every sector. For Mexico, the waves are much smaller. We only have leather, transports, house with a person, food type, are sectors that high technology, you require highly skilled employees, and don't have in general don't have high linkages with the rest of the economy. So I think in every aspect that we evaluated, we can see that the potential benefits of Mexico with this relation with Canada and the US, in particular, when we target the manufacturing industry, are very limited. So one thing that I put in the table that Mexico could do, and it's not only me, you can find it in the literature, other authors have pointed out, is that first, Mexico has to develop more input-output linkages with its production network to connect the manufacturing industry with the rest of the economy. And then Mexico can see if an export-oriented model could benefit the economy. But if the manufacturing industry is not well connected, then an export-driven model will not work, even within a free trade agreement with its neighbors. I think those are the main points. I don't think we have much more time, but you can find more information on the paper. For future research, well, we have two points, which is to relate or associate these results with structural properties of the networks itself. So some network properties like centralities and something like that, and other types of shocks and other types of spreading models will also be interesting to explore. So thank you very much.
Thank you, Marta, Gabriela. Alatriste. Thank you, Alatriste. We open to Nico.
Okay, yes. Can you give me permission to share the screen?
Yeah. I don't know how to do that, but let
Okay,
me.
I
Dejar, yeah, okay. Ready. I'm sorry.
there it is. Okay. Sorry, can. Okay. I have here.
So you have some assistant there, Nico.
Yes. My assistant is coming. He's actually she wanna make your. She wanna. Okay, there it is. Oh God. I can't find I have too many screens here. Okay, let me take out this. You here. There it is.
It's a bit tricky,
Sorry.
right? I thought it was easier. For me, it's a bit tricky to share a screen and everything.
Sorry, there it is. There we are.
Perfect.
Okay. So first of all, I mean, the authors. Thank you for your presentation, Marta. And the author, what they implement is this model for studying the spread of a shock through the network of activity. So I just put here a very simple, idea of what they've done is just you have a shock here affecting a sector, particularly in manufacturing, and that spread through the whole network. Mm-hmm. So what they implement is a particular rule at how this shock spread from one sector to other sector. And what they do is Marta presented just a couple of minutes ago, which is this inequality. This 3.7 of the paper, or the equation number 4 in your presentation. Mm-hmm. And what I want to point out is that this equation can be expressed in this way, as I am writing here, mm-hmm. where what you have these two terms here. This first term is basically all these are, let me see. Okay, these are all the intermediate buys made by industry J, okay. And these are all the intermediate sales made by firm J. Mm-hmm. So if you organize the terms, you end up with this expression, which is the shock will spread to another sector. Well, this J here is the value added of the sector J. And this DJ is the share of the income, of the share of the revenue of the sector J, which is coming from final demand. Okay? Mm-hmm. So if you look at this, what we have here is that the probability that this triggered rule spread the effect depends on whether the sector has low value added, and whether the sector, you know, the revenue of the sector is not coming from final demand. So basically, the lower this term and the lower this term, the highest the probability is that you will have spread the effect across, you know, from one sector to other sector. And I think that that is quite interesting what you are putting in the model. So in the spreading mechanism, what you're saying is, look, all the sectors that have low value added, and all the sector where that they are getting most of the revenue is not coming from final demand but from intermediate demand. All those sectors will be more affected by this shock. You know, everything equal. So what I'm saying is that this measure of resilience, the C divided F is constant. So if that is the case, I think that it could be interesting, you know, to think in these two comments. The first is how you will, you know, what will be the interpretation of this phrase that you put, North American regions show that spreading effects are more widely spread in the USA and NAFTA network and more narrowly spread in Mexico. So what you're saying is, if that's the case, that, you know, in North America, or if you say in USA, the effect is more widely spread because the sectors in the USA economy, they produce lower value added, or their revenue is coming from intermediate demand, not from final demand. Well, I don't know how, you know, because it's exactly what they're saying is what they're doing is exactly that, but it's nice to make that alternative interpretation. That's one comment. And the other comment is related to somehow, let me go back. Go back. So what you're doing here is that you are having some perfect degree of substitution. So let me put it in graphically. You know, this red line here is the C divided F. What you are saying is that, you know, the shock will spread in all the cases where the sum of this plus this come in this big area. So what you're saying is some perfect degree of substitution between a sector that has low value added and a sector that has low share of revenue coming from final demand activity. I don't know how I don't know whether that should be like that, because what you're saying is that something like backward propagation is substituted with forward propagation, somehow, something like that. So I'm making these two comments just for this, like, open more discussion more than okay. Thank you very much for the paper.
Okay, thank you, Nicolás.
Yeah, Marta, if you can answer or you comment to the comment, or what do you want?
Okay, so thank you, Nicolás, for your comments. They're also very interesting. I think, though, that when we should be careful when interpreting this rule with value added, because intermediate demands are not exactly value added in the input-output model. So we're not actually accounting for wages, benefits, etc., that are produced in each sector. It's just the flows of inputs. So actually one way to analyze or to interpret this rule in terms of networks is just in strength and out strength or weighted degree of each sector. So I understand what you're saying. I just, with my comment, I just don't know if this perfect substitution between low value added and low final demand would be the case. Of course, in reality, it would not, but according to this rule, I'm not sure we have this perfect degree of substitution. And for sure, I don't know if that would be the case, especially for the US, because we wouldn't have this perfect substitution between backward linkages and forward linkages. No, I think in the input-output literature, they will kill me if I say that. But
okay, let me tell you. Sorry, I think I have to explain you a couple of things.
Yeah.
Marta, this is exactly. If you divide these, so if you look at this, these are all the expenditure.
Oh, okay, you're dividing between X.
If you divide this, so you take this equation and you put it in the left. You put it on the other side. Okay. What you have here is all the intermediate expenditure made by the sector J divided the gross production of the sector J. So the complement of that is value added. And that is, this is why I'm saying you here that what you're putting is
one minus
value added, in the sense that, so you are leading with the complement, and the complement is the intermediate expenditure of the sector J.
Yeah.
So the intermediate sector of expenditure of the sector J is greater when the value added is lower. So remember that input-output matrices are national accounts. So this is account. So 1 plus 1. So this is why I'm defining this as value added, and actually has a complement of value added, which is exactly 1 minus value added is intermediate expenditure.
Okay.
It's the share of your expenditure that it is put it in intermediate. This is not exactly the same because you are changing here the value of xj, but it is very close. And this is exactly the same here. And what is this? This is backward. So this is basically backward propagation. And what is this term is forward propagation. So this is a Gauss equation. This is a Gauss matrix. And this is a Leontief matrix. So this is there's some small computation that you should make, but this is pretty much what I'm saying.
Okay.
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 So I think this is, but I think that this is a quite interesting, interpretation to look at the data and to look at the mechanism that you are applying.
Yes, for sure. Thank you for the clarification. And it's especially interesting because the Mexico actually always linked to the fact that in particular the manufacturing industry in Mexico is the one in the whole system that has the lowest value added. So that's actually one of the problems in Mexico, that all the export sectors that are the manufacturing industries have the lowest value added of the region for Mexico, and not the case for the US. So it's particularly interesting, this interpretation for that. So I haven't seen that that relation to value added, but for sure I will. It's very interesting, and I think it's linked to one of the future points that I would like to make with the structural properties of the network. Yes, thank you.
So do we have, let's say, a final question for Marta?
Mm-hmm.
Excuse me, Marta, but we have, sorry, but we have, you know, the amount of time is limited. Okay. You can also contact Marta later.
Yes,
But is it, anybody wants to ask something?
I think there's questions at the chat.
Okay, so take one.
But the first one, I think wouldn't be interesting. I don't know if there is information available to incorporate other sectors beyond the manufacturer as a shock in the manufacturer could spread, for example, to the agriculture sector by increasing the demand on that sector. Okay, so I think there's 2 points in this question. First, of course, we could extend the analysis to analyze the effects of shocks on other industries besides the manufacturing. We could shock any sector. Since we're executing simulations, we could actually evaluate any scenarios we would like. We focus on the manufacturing industry because one of the targets of the free trade agreement within the region was the automobile industry. But the aggregation of the database wouldn't allow me to actually target the automobile industry. So I had to go with the manufacturing industry. But if it's interesting for someone, you could do it for any sector you would like. That's one part. And the other part is in these waves that I talked about, you could actually see how a shock on manufacturing could reach the agriculture sector, for example. So you could see that here I'm just talking in the air, but you could actually see that, for example, for Mexico, the shock on manufacturing would reach the agriculture sector in, I don't know, 3 steps. And for the US, it will reach it in 5 steps. But you could actually see that spread in the paper, no? How other sectors are being affected by the shock. So I think it's those 2 cases. One, the shock could be hitting any sector you would like. And also the shock on manufacturing is actually affecting other sectors, including the agriculture. Yeah.
Okay, thank you very much, Alatriste.
Thank you.
And we have now Daniel Heyman. Are you prepared, Daniel? Or
yeah. So
okay.
Can I go?
Yes.
Okay,
please.
Thanks for the invitation. I'm glad to be here. Let me share the, wait. Do you see the presentation?
Yes, yes.
Okay, good.
You can see it.
So this is what I want to talk about. This is a very unpretentious paper. And actually it became less and less pretentious as time went by in the preparation of the paper. So it may be relevant if you want to tell a little bit about the inside story of the paper. So in the first place, this is a mixed team of 2 economists and 2 physicists, and you'll see that the difference was relevant for the content of the paper. And we were playing with the notion of doing some macro agent-based application, something like that. At a certain point, we became stuck in the pricing equations or the pricing representation of the model. And while discussing among ourselves, the Bertrand-Edgeworth scheme looked promising in the sense that it's a price-setting game with a little twist that it incorporates capacity constraints. Okay, and we were thinking about shops in a city where the shops have price competition. You can think about that, and they have capacity constraints. I mean, the shop can take so many customers at a time and stuff like that. So the economists then, once we thought, well, let's explore a little bit this scheme, which has very interesting analytical properties, in the sense I will come back to that in a minute. It doesn't have a pure strategy Nash equilibrium, and it's very easy to show. I'll give you the idea of the argument in a second. So it looked promising to investigate this scheme. And the economists, we were trying to find clever strategies of the agents of the model, clever strategies to try to find out or at least approximate an estimate of the price elasticity of demand, stuff like that, and do some optimal calculation or reaction function. We got stuck there. So now comes my physicist friend Roberto Peraza and says, cut all this nonsense. Let's put it this way: if you sell at full capacity, you raise prices. If you don't sell at full capacity, you lower prices. And we said it's really too simplistic. And they said it's realistic. I think it's going to be there. We couldn't more or less agree, so we decided, let's do experiments and see how they go. So and that's the basic thing that led to this paper. So price setting with capacity constraints, it's an interesting problem, I think, and it's potentially a simplified representation of actual markets. There is no pure strategy Nash equilibria, and the mixed strategy equilibria are difficult to characterize. That's known in the literature. On the other hand, there is some literature on experimental plays of this game, and it's found, and we find more or less the same, that mixed strategies, equilibrium mixed strategies, are not found experimentally or cannot be identified in the data. So what the paper wants to do is to study the Bertrand-Edgeworth market in a very simple form. In particular, we don't play with information about the strategies of other players. So the agents decide only on the basis of their own history of plays in the game. And we explored some simple price setting rules to see whether they can more or less represent the behavior in the market. And that's another point I would want to go back to. It's very hard to find an optimal behavior. And that's one thing that we find in the experiments. So we want to explore simple price setting rules. We want to build simulations with agent-based models based on simple price setting rules. And then we want to check whether experimental experimental setting more or less corresponds to these very simple rules, and whether using these rules the actual markets can be more or less simulated. Okay. And so we analyze and simulate basic properties of simple pricing rules. We conduct market experiments to contrast behavior with simple heuristics. And we use parameters of the heuristics calibrated from the experiments to simulate market behavior and see whether it approximates observed experimental features. Main results: an experimental evidence favors my physicist friends' conjecture. Very simple, very simple. And something that I want to stress is this. Okay, I think I'll make it quick because my message is basically that. The experiments were played by quite competent people, more or less, in our industry. People who were either graduate students in economics and some physicists. So, and they were absolutely informed about the game. We told them about the game. We told them that it didn't have a pure strategy Nash equilibrium. We told them about the reason why there wasn't a pure strategy Nash equilibrium, and in a sense gave them and let them know, so to speak, the characteristics, the strategic characteristics of the game, and we let them play that. And one thing I would want to stress, because that's relevant, is a comment by one of the guys who did well in playing the game. He was a very smart graduate student in economics who knew his optimization and so on. And he said, I was trying to optimize. And after a few rounds of the game, I found out that was not the way to go about it. So the guy found out that trying some simple heuristics did better for him than trying to be too smart. Okay. And it was very interesting. So the other thing from the market patterns that result from this game, it's interesting because, again, you don't have a pure strategy Nash equilibrium. However, market behavior tends to show price convergence to some sort of quasi-stationary states, somewhat higher than the competitive price. Okay, so even if there's no steady state in that respect of a pure strategy Nash equilibrium, the experimental behavior more or less converges to something in normal times. But you have price excursions when market price nears competitive level. There is some feature of the model that's called Edgeworth cycles. And let me move. Okay. So two things, and I'll stop there to make it quick. One, why isn't there a pure strategy Nash equilibrium? It's very simple. Suppose, for example, and that can be easily generalized. By the way, the math of the paper is adding, subtraction, multiplying, and dividing, basically, so high tech. So suppose you have n players, n minus 1 players fix, let's say, the competitive equilibrium price. Okay? And the competitive equilibrium implies an equilibrium price which is higher than cost because demand is sufficiently strong. By the way, what we have, the game which is played is there is an aggregate demand in the market, so there is as if there was customers who came to the market with a certain amount of money, and they would spend the money in the good. That was it. They were in the market, all money had to be spent, so to speak. So, and the money was sufficiently large, or demand was sufficiently large compared with the cost of production, that the price, the equilibrium price, I mean, the competitive equilibrium price would be higher than cost. So suppose that everyone else sets the competitive price, n-1, and you are the nth agent. You see that the whole amount of money is not spent because of the capacity constraint. The n-1 people who set the competitive price, they sell all their capacity. And now the nth agent has absolute monopoly power over the rest of the demand. You see the point? So if n-1 set the competitive price, the nth agent has an incentive to raise the price enormously. Okay. And it can be shown that that's more or less the pattern. If the other people set a very high price, you do better by lowering your price a little bit below the price of the competitor, so you capture at a high price capacity demand. You sell capacity production at a very high price, and that's good. If they set a very low price near the competitive price, then you're better off sending the price enormously high. And that creates the potential for this sort of behavior. And we do find, let me change a little bit the presentation, and I'll show you some pictures. Well, this is a simulation. I don't have time to go through it, but I'll show you some simulation results. Well, this is an error. There are errors. Some people make mistakes, but you see this simulation. We did 11 experiments. You see the average price level, the highest price level, the lowest price level. Here is a mistake, but you see the price starts above. This is the competitive equilibrium. This one is the competitive equilibrium. This is a limit that don't have time to talk about. So the price starts above.
Daniel, we can't see the pictures.
You don't see it?
No.
I see. Well.
You have to stop sharing this one and start sharing the other one, I think.
I have to stop sharing the other one. Well, okay. Let's stop sharing the other one. Now?
Not yet.
Well,
now you have to select share the one that you want to select to share now.
Yes. Okay. Now?
Yes.
Yeah.
So this is reporting one of the experiments. You see, it has some ordering. It goes down, 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 down. And when the price gets too low, you have these excursions. So, and more or less, it's not that clear here. In another experiment, the thing is more ordered. but you still have this. You have these sudden movements, and the other thing is that you see you get some behavior which is relatively constant. It looks as if it's a steady state, but it's a metastable state, so to speak. Okay, and you have attempts to raise the price. Then competition comes, then the price goes down. The system tranquilizes, so to speak, and it goes, and you have this sort of intermittent behavior of ordering and exploration by the agents. In some cases, the exploration is very strong. Here, for example. Here, there was one guy, this is an experiment with few agents, and you see, this agent was disturbing the market. There was a small number of players, not very competitive system. There was one agent who managed to obtain very high profits by playing around this strategy. So, and we verify that essentially the behavior of agents can be represented very simply by this basic rule that says if you sell at full capacity, you raise the price, or, and that was discovered exposed, or you keep the price constant. So there are some people don't want to, when you see they sell at full capacity, they restrict their exploration, so to speak. They are content with that at some moments. And if you don't sell at full capacity, you lower the price, basically. And these simpler heuristics are more or less sufficient to simulate the model, having pictures of the price setting, which is more or less replicate the main features, qualitative features of the experimental results. So let me conclude, and I'm sorry for taking your time. And let me read directly. In an environment that does not allow the ready identification of profit maximizing strategies, the behavior shows more or less approximate correspondence with some basic heuristics, but not mechanically. The search for improved performance was reflected in changing parameters of response to realized outcomes. In occasional excursions where some players implemented discrete changes in the reaction function. So that's more or less the message that I want to take to you. It's, of course, how this generalizes or not is up to question, and I wouldn't overgeneralize or even generalize without more work. But I think, to conclude, that in a sense the combination of a little bit of analysis, a little bit of simulation, and a little bit of experiment does make some sense when one thinks about doing agent-based representations. So thank you very much. And I get this.
Thank you, Daniel. I think we will come back to something close to your paper with Nico in the next presentation. Thank you. So, Fernando, you're here?
Yep, I'm here.
Thank you very much for being with us. We ask you to comment the paper of Daniel.
Thank you. Thank you. First of all, thank you, Daniel, for your paper. It's a very interesting contribution, and it gave me a lot of food for thought. But first, let me say a word about one of the authors of the paper, Enrique
Yes.
Kawamura,
Yes.
our dear friend and colleague. His
Yes.
early passing.
Not with us anymore, and that can be a tribute to a
certainly.
very special person. Yes,
certainly. And his passing was a heavy hit
tragedy,
to our
yeah.
community. He's sorely missed. So, but let's go back to the paper. What are the main takeaways that I found in it? On one hand, it's interesting to see that it again confirms that Nash equilibria, and more than that, mixed Nash equilibria, are very hard to obtain in real-world settings. And that's the reason for that is that, as shown by the work of Adam Brandenberger and Robert Aumann, the epistemic conditions for Nash equilibrium are so demanding that there are very few situations in which they are fulfilled. And for instance, in the experiment carried out by you guys, it's clear that those conditions cannot be fulfilled. So we cannot expect that agents will settle on a mixed Nash equilibrium in that context. But what worried me a little bit, was a little bit worrisome for me, was the result that the most simple heuristics improved over the results of the more sophisticated one. It's something analogous to what happened when I first read about Axelrod's experiments with Prisoner's Dilemma. How come that tit for tat is so much better than other algorithms that are so much more sophisticated that they seem to be using information, a lot of information of the game, but that does not give them an advantage facing tit for tat. And that's repeated here. The other heuristics you use, it's a kind of a version of reinforced learning.
Reinforcement learning, yes.
Yeah. The thing is that maybe we can think in other reinforcement learning algorithms. I'm thinking now on what is called GAN. I don't know if you heard about it. It's generative adversarial networks. It's one of the latest developments in deep learning. And it's an architecture in which you have two networks, one trying to outsmart the other. So in the end, the whole system learns better than with other alternative architectures in deep learning. But so it's used, for instance, to detect fake photos or fake videos. But even so, I'm thinking that suppose that you use this another rule, another more complicated rule, and it improves a little bit. But the thing is that still this simple heuristic matches very good the results you find in the experiments.
Yeah.
So that means that agents really don't use information even about their own profits, and less than that, they don't build a model of the whole situation. They don't even conceive the existence of other retailers in your experiment. So that can be worrisome in a sense that where is agenthood there then? But then I think that there might be another alternative, a more unsettling in a certain sense. And it's this problem or analogous problems are actually equivalent to some more simple problems for which this simple heuristics or other simple heuristics are actually the optimal solutions. I'm thinking in something like the complexity classes in like NP n equals P problems, in which if you have a solution, a P solution for a problem, then it also solves a lot of other problems. So maybe there is an equivalent problem to this one, which is quite simple and for which it is optimal. And so this guy who said that he wanted first to optimize, he was trying to optimize the evident problem. But maybe this evident problem is disguising a much more simpler one in which the solution, the optimal solution, actually consists in being very simple. But this is just a conjecture. I think that maybe for this, more work is needed. I mean, trying to run other simulations, use other algorithms to check out if the results can be improved. But if not, then we have to consider seriously that there might be something hidden here that deserves really another alternative approach than the traditional in economic theory. But thanks again let me just a final word about the experiments. I have the feeling that experiments in controlled situations like they are usually run are interesting sources of information, but we should take them with a grain of salt, because we found in our own experience that sometimes people do not behave exactly in experiments like they would do that in the real world. This, journals in the field ask experimenters to give money payments to experimental subjects to ensure that they have the right incentives. But the whole situation is kind of artificial. So we don't know exactly if people will behave in that way. But even so, if we take an experiment like the one you run, and we would like to find why this simple heuristic was the better solution they found, and that's a very interesting research question. Thank you.
Gabriel.
Yes, you have time to comment the comment, or
okay. And then we comment the comment. But
yeah,
and so on.
So on and so on.
Well, thank you very much. Thank you very much, Fernando, for your comments. And I mean, they are deep. So what can I say? I think we were thinking about why the more sophisticated, we with Enrique Kawamura, we devised this reinforcement mechanism as a counterpoint for our physicists' simple-minded scheme, and said, no, you see how people do it. Now, when you take a look at it, it's not that good in this respect, to be specific about the game. So you follow, if the scheme is this, for the rest of the audience, the scheme is this: if you raise the price and the benefits went up, then you raise the price once more, and blah, 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 blah. And if you lower the price and the result was increasing your benefits, then you lower the price a little bit more, and that sort of thing. Now, in that respect, you are condemned to, you lower the price, you raise the price, you don't sell, you lower the price, you sell, and you lower the price again, so you're amplifying the movement. And in a sense, you may get, and I think my conjecture is that, you may get stuck in this thing that you do it too fast, too far. You lower the price too far when it went well, you raise the price too far when it went well, and maybe the other one, the simple one, eliminates this sort of echo.
Mm-hmm.
Okay, maybe, but you are quite right. One may explore, and it would be very interesting to, let's say, if one wants to play again with this model, to have a battery of heuristics, like Axelrod did at the time. So this, as you point out, is a sort of tit for tat. Okay, and then let's play more sophisticated and see whether they match the experimental evidence. And I think it's a great point that you made, that maybe underlying this game there is another game, which is where simple rules go well. That may very well be the same. About experiments and the grain of salt, you're absolutely right. I wouldn't go to the real world applying a thing like this, but I can tell you, the feeling is these guys were motivated. We paid them, by the way, not very much money, because as you know, blah, 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 but they were paid. But they took it playfully, in a sense. Okay, so they wanted to do it.
Yeah, they were engaged.
They were engaged. They liked the thing. It was fun. They played with the computer. Blah blah blah. They were graduate students, and they say, "Ha ha."
Good.
So, and okay, external validity is a problem always. So
always,
this is one example of a multiplicity of examples. But really, thanks a lot for the comments.
Thank you. Just, can I say something else just to finish?
Yes.
Yes, sure, Fernando, yes.
Yeah, thank you. It's the comment to the comment on the comment. The thing is that when I saw the reinforcement learning algorithm, our rule you presented in the paper, I thought, I realized that it overshoot every time, because it depends so critically on the parameters that if you don't have some way of, you know, refining them and calibrating them, you will be always over or below the real thing. But as you realize, deep learning is my new fad, and I'm learning a lot about that stuff. And they always design their systems to not only to find a solution to the problem by itself, but also try to hit the real model of the situation, to try to catch up the latent variables, the variables that are not under control, the system itself. So maybe there is here something like a parallel, a dual optimization procedure. One is maximizing profits, but the other is trying to catch up what's going on outside my shop. And
Yes.
maybe a rule that involves these two things. That's what I wanted to.
The extension would be to give these guys the information about pricing of the other.
Exactly.
That's the point that you make. Yes, of course.
Exactly. But that's really, I don't believe that it would be more than a, marginal improvement.
Because it's too complicated.
It's too complicated, and humans do not spend so much time thinking about the things, right? So, but thank you. It was a great contribution, and I really like to do. I had a great time reading the paper.
Okay.
About that.
Okay. Thanks a lot. Thanks a lot.
Thank you, Fernando. Excuse me to cut this dialogue, but so do we have more questions for Daniel? Somebody wants to ask something more? Some comments? Oh, okay, thank you, Daniel. Thank you very much for the presentation.
Thank you for listening.
And now we have Emiliano. Your microphone, Emiliano.
Okay, and now can you hear me? Yes?
Yes.
Okay. So, hello everybody. My name is Emiliano. Well, I want to thank the organizers of the event, especially on the difficulties to carry out an event this year. Well, also my co-authors who are here, Silvia and Gabriel, and the research group on economic dynamics of Uruguay. And in this presentation, unlike the previous ones, I want to present the results of a bibliographic review and a bibliometric analysis, analyzing the articles on social simulation that follow the principles of the ODD protocol. So I want to share the screen right now. So you can see it?
Yes.
Okay. Well, just give me a second. We'll show the comparison with the articles that use ABM, Asian-based models, in social science, and see the similarities and differences between both sets of works. So we want to compare the articles that follow the principles of the ODD protocol. The ODD protocol is overview, design concepts, and details. We'll see it later. And we will compare with the articles in ABM in social sciences. Our first conclusion is that there are groups that deal with different topics. That indicates that this standard in ABM documentation has not yet become a standard, but this penetration has been uneven on the social science. Okay, so let's start. Okay. First of all, the motivation. Why should we use Asian-based models in social science? Here am I quoting an article by Hilbert here. But there is a consensus as to what social simulation allows us. The possibility of observing macroscopic processes as an emergent process that arises from the interactions between simple agents. Okay. Now, why should we document these models? Okay, it is important to note that there are several authors. Here we are only mention a few that show some problems that arise from the increasingly complicated models that are made to analyze complex problems with a higher degree of definition. There is a need to find a standard or a common language, a lingua franca in terms of the article of Garrido and other authors. This standard has to be able to communicate the different stages of the modeling process. So how to build a model, how to describe it, analyze, evaluate, and also replicate an agent-based model. Well, it's a clarification. Now we are going to talk about the importance to the communication of the model, but it is necessary to communicate many other aspects. Okay. Well, and also there's another thing that why we should document the models, because these models, agent-based models, they are not simply equation-based models. Okay, we cannot only define it with equations, but we need some other aspect that we should take just a moment to talk about it. Well, okay, let's begin with the introduction. What is the ODD protocol? It's an acronym for overview, design concept, and details. Well, we don't have many time, so the importance of it is that facilitate writing and reading of model descriptions, making them understandable and complete. They enable replication of ABMs, establish a set of design concepts that should be taken into account while developing an ABM, and it is intended that the essentials of the models are described appropriately. And we said just a quote of the article of Prim and other authors, that they say that this set of things create a generic format that the standard structure with which all ABMs could be documented. Well, it's just the structure of the model following this protocol. The phases have some small changes over the years. These years, many aspects of the protocol have been improved and clarified to make it easier to modelers to use. So the first paper was from 2006, and there's some updates. Okay. Well, now I review some articles that follow reviews on ABMs and simulation social sciences. Some examples are migration, management, or innovation diffusion. Here we must make a distinction in the sense that Squazzoni does. Using ABM not only allow us to work with well-established problems, but also allow us to work with other issues, from which it is only possible through a multidisciplinary approach. Next, we must think about some differential aspects of ABMs in social science. Here are heterogeneity of behaviors and analysis of social dynamics. Okay, the analysis of decision making, analysis of social dynamics, things that using for humans. Okay. Because humans are thinking particles, so ABMs have to be thinking about that.
Emiliano,
well, yes.
Can you enlarge the presentation? Because it's too small.
Okay, just give me a second.
You can put it in full screen. This is okay.
This is fine.
Okay.
No.
Give me a second.
Now it's good.
Okay. Now it's okay.
Yeah. Yes.
Okay. Okay. Well, we're talking about, well, another relevant aspect is the importance of journals for the dissemination of these concepts. Okay, the last point. Some of the works we mentioned that here follows this approach, analyzing the articles published in SHAS. SHAS is a Journal of Artificial Societies and Social Simulation. Someone of you may know it. Advancing the results, I would mention that SHAS is a journal where more articles have been published within the articles that appear in our database. So JAS has an importance in the dissemination of social simulation concepts. Well, these are the questions that we make. The first is about whether a standard has been achieved to document ADMs. Well, the second refers to whether the ODD protocol has been introduced to social science and in which areas. From the data collect, we will also show which are the most developed areas and which are the forerunners in each area. The third question refers to whether we can find differences between the articles that follow the ODD protocol and those that do not. And the last question, we will look for evidence to support the claim that these protocols allow greater communication between academics and between disciplines. Okay, well, talking about the data. The data extraction procedure we carry out is similar to works of Grimm and other authors in 2010 and 2020. We'll take into account the articles that cite Grimm and other authors from 2006 and 2010. The data collect was taken from the Scopus database. The last access was on August 31. And the quantity of articles was 1,527 papers from the first one and more than 1,000 also from the second article. Then we filter by areas. We only take articles from the economics, social science, business, or decision science areas. After the filter, we have almost 600 articles. And finally, we eliminate the duplicates. That is, those documents that cite both articles. In total, we work with 440 articles. The Scopus database has a lot of information, which will allow us to perform different analysis. We have information about authors, title, abstract, keywords, affiliation, country, years, and references. Talking about bibliometric analysis, we'll see the co-citation analysis. That's the frequency which two documents are cited together. Look at the picture on the right. Okay. Picture on the right. two articles depend on the number of occasions on which they are cited together. Okay. How many times? So, well, we'll start with the results of the results of the ODD literature. Well, the first one is the annual scientific production that grows from 2006. Well, a sustained growth in the number of new articles. This growth becomes more important in 2010, where the article by Puchet and other authors in JAS, and the article of Grimm and other authors from 2010, where the update of the protocol is shown. So there are several updates of the protocol. The last one was this year. So then if we see the most productive countries, both in authorship and co-authorship, are from the European countries and from North America. Well, something that we should note is the proportion of articles whose authors belong to more than one country. Okay, the co-authorship from more than one country. That is a result that arises from international research networks on the subject, which we will see later. Okay. Now, well, the most relevant sources. Here we observe that JAS is the journal with the most publication in social sciences within articles that cite Grimm or 2010 or in 2006. Here we can observe also that the 10 journals with most publication, we have journals related to simulations or issues that related on ecological or environmental problems. Well, seeing also the most relevant keywords, we can see two data sets, the keywords selected by the authors and the keywords that are assigned by Scopus. Okay, we show both rankings, and we will know these keywords in different categories. First one is the importance of Asian-based approach. It is in bold and in blue. Okay. As we can see in both classifications, it is among the most used keywords, also linked with other important ones like model or simulation. Okay. Well, we also select individual based. Okay, it's a link between Asian-based and individual-based concepts. It's a paper of Pinsnot that is an excellent bibliometric analysis that you should read. Well, second is the emphasis on simulation and computational models. That is not surprising, because simulation is a fundamental aspect of these models. Third is some empirical and methodological aspects, the replication and validation. These aspects are related to the possibility of model communication. The last one is topics for behavior or decision making, and economics and ecology, the links between ecology and economics. Well, okay. We will see, the idea here is to represent chronologically the most relevant articles in a field of study. We create a map to observe the most relevant articles, the links between them, and which of them have helped to open new fields of study. on the next page, we'll see the map. And here we take the 3/4 of articles with the highest number of citations. We see 75% of the articles with the highest number of citations. And well, to represent it, we plot with the 150 articles with most citations. Here's the map. Now, most of the literature arises from the article of Paul Hills and other authors from 2008 that talks about land use change. Apart from this main group, we can see other topics that emerge, such as industry networks, disease spread, issues related to resource conservation, such as circular economy, analysis of policy interventions, analysis of urban mobility as a complex system. The analysis serves to find which are the fundamental references to the area. Okay, these are the references. And these are the main group and other articles who are different topics. Well, this is the same network with the main group who starts with the article of land use changes and other articles that are outside this main group, okay? And now only look at the 30 most cited papers of our database, which allow us to identify some lines of research that emerge from Paul Hill. This line of research refers to topics at energy efficiency, tourism, output analysis, feedback within natural and social systems, and also on modeling, ODD, and methodology. Well, the co-citation analysis we perform here, we Lorraine clustering algorithm and found 3 clusters, which refer to 3 different kinds of articles. Okay, in blue, well, the main articles, both on citation and in centrality. In red, we find the articles that are the references, both in the ODD protocol and in the use of EM, as well as in the most commonly used software, NetLogo. It's here the references. And in green, this group, we find a cluster of articles that are less central and that serve as a reference for land use and land change topics. Well, these are just the table. If we see the keywords co-occurrences, we can see 4 groups. In red, a group related to economics and decision-making process. In blue, relate to spatial analysis. In green, relate to modeling and simulation. And in violet, this group relate to computational methods and topics related to land use and ecology. Okay, 5 minutes, okay. Well, these are the collaboration networks. In left, we have the collaboration networks between countries, and on right, the collaboration networks between research centers or universities. What results we can extract from these networks? Well, some results are the main research centers are located in the United States and Western Europe. These research groups are the link between research centers in different regions. Also, many countries are only linked with one of the core countries, or many countries are disconnected from the network. talking about research groups, they are related to the main articles of the topic. Okay. Well, now we'll seek to analyze the articles that use ABM in social science. For this, we carry out a new search in Scopus, which includes the concept of Asian-based model, limited to articles in the same categories we mentioned before, and we have more than 1,000 articles. Well, we have the co-citation analysis. Well, we have 2 groups. These groups, we can say that in red, they are the most cited articles, and those that deal with the most important topics on ABM in the social science. Okay, economics and social system as complex system, fundamental articles of network analysis, and others. On the other hand, the blue group is made up of some review articles and articles that seek to link the social science with ABM. Here we note that the article by Grimm and other authors of 2010 is weakly linked to the core of ABM articles in social science. Here it is. Great, you can see it. This is an indication that shows us that the ODD protocol has not yet managed to generalize its use in the social science. Okay. Well, looking at the keywords, we see 3 groups. One with the most used keywords. The second one linked to game theory approach and the links with complexity. And in green, a group who manage with simulation modeling linked to multidisciplinary topics. For example, segregation, norms, learning, climate change. Yeah, okay, multidisciplinary topics. Here, we'll show something interesting. A comparison of the most used keywords, both in the articles that follow the ODD protocol and the articles of ABM in the social science. Above, we see this comparison with the outdoor keywords, while below, we see the same comparison with the words assigned by Scopus. If we look at the 2 classifications, we see that there are many similarities in the most important ones. ABM, simulation, social simulation, modeling, etc. Now, let's see the differences, which are both in the topics covered and in the methodological emphasis. In the first case, we find land use and climate change compared to social influence, cooperation, and game theory. On the other hand, we see that validation and replication have greater relevance in articles that follow the ODD protocol. Here are the most relevant sources. Again, JAS appears as the journal with the highest number of publications. Subject, which supports the mentioned reviews of 2013 and 2017. And on the other hand, we find differences with the classification of the literature that follows the articles by Grimm and other authors. Now, many economics journals appear, are in bold, which suggests that, in particular, the ODD protocol has not achieved significant advances in economics. We also appreciate that journals with a broader spectrum disappear from the list, which may mean that there are differences in the level of integration of the different disciplines. That is, we find more multidisciplinary journals and topics in the document that cite Grimm's articles. Okay. Then collaboration networks. Well, the results are almost the same. The most relevant research centers are in the United States and Europe. The country network is star-shaped, as in the previous case. Okay, it's a core periphery network. And let's look some metrics of collaboration networks to learn how information circulates in these networks. Well, some results are all networks are small world networks. Okay, 1 minute. Okay, I almost finished. The density of the network, let's see that. The networks of research centers of the countries of the dataset that follow the ODD protocol have more links per node, have higher transitivity and a lower average path length. Okay, that is, information circulates more fluidly through this network than in the network of ABM in social science. As we indicate in the slide, a possible explanation of this fact is that this protocol allows better communication between the researchers and facilitates the replication of the models. And well, conclusions. Our results show that there are advances in the ODD protocol in social simulation, but however, it's not yet a standard. Okay. Second is progress can be seen in the literature. We talk about the most developed areas. The literature that follows the ODD comes from the same regions, but both countries' networks and research centers' networks are different. And the results previously seen indicate that more multidisciplinary work appears in the literature that follows the ODD protocol. Okay. Future extensions is using other databases, focus on social interaction and social learning, and also perform a comprehensive bibliometric analysis of complex systems in social science. Well, okay, these are the references, and well, thank you.
Thank you, Emiliano. Long presentation. So, Alatriste, do you have something to comment?
Sí, ya lo estoy preparando para. Yes, I am.
Okay.
About to share screen.
We see the presentation.
Yeah, you see it? Perfect. I learned. Okay, but Emiliano, thank you so much for your presentation and co-authors. This is a very interesting and presentation, study. I think it's really pertinent. So let me just first talk about the paper, and then I'll give my points for discussion. So authors review communication of agent-based models in social science, in particular in more economics than in general the social sciences. And they argue in favor of having a protocol, the overview, design, and concept and details protocol, to better communicate these models used in this type of studies. And I think one of the most important reasons why this should be out there is because we need to enable replication. It's one of the main problems I have found, especially in the social sciences and economics, is to enable replication and to be more transparent about the model and what we are doing exactly. So, well, for their study, they use the Scopus database, and they do bibliometric techniques. And what they found, I think it's pretty interesting, but I think it points out we are still behind in this need of replication. So one of the strengths of this agent-based modeling is precisely they are very flexible. They allow to include a lot of elements to our models, but at the same time, this flexibility becomes its weaknesses, because we have this diverse way of modeling. We have so many elements that we can include, and I have found models with a lot of parameters and a lot of equations, and sometimes you don't find any equation at all. So this flexibility in establishing this type of models, I think, is at the same time one of the weaknesses. So it's evident we need this common methodological standard. I don't know if this ODD will become that standard or it has the elements that we need for establishing that standard. I just want to put out there for discussion, if we can establish a standard, what would it be? Because maybe the ODD, it's not exactly, I don't know, it's not exactly the standard we need in social sciences and in economics in particular. So maybe instead of pushing for a standard, a structure, a format, maybe we can just start by motivating, sharing of data, the sharing of the code that was used for the analysis, and the algorithms that were followed in order to apply the model that was written. So it's not only how to communicate the model, but it's how to communicate all other things around it, in order to enable replication. So I think one of the most important things here to rescue is replication. And also another important thing surrounding this issue is be able to open these channels of communication within these researchers. So we have multidisciplinary groups working together, but also there are, I think, not so much communication between the groups. So maybe if I want to replicate something, I can just write to the other group and say, I want to replicate this, but I don't understand your model. Or could you make public your code or something like that? And in order to do that, I think the open science framework gives a pretty good opportunity, to start this this way to I don't know if a standard, but at least a way to enable replication. Okay, so thank you so much.
Thank you very much, Marta Alatriste. Do you have a quick reply? Do you want to, because we are in time to the last presentation, the final presentation.
No, just thank for the comments, and it's right. We did a framework to communicate the models and to be easier to communicate the models. So yes, of course, I don't know if we need a standard that we will use always, but we need to replicate models, and we did a form that communicate that all will understand the model. So, okay, thank you.
Thank you very much, Emiliano. And I'm sorry we don't have time for more questions because in 25 minutes we will be cut. So we cancel the sixth paper, the paper of David. It will be presented next Thursday in our seminar. So people who want to have information, just go to our web page of our research group. And now we have Nico. Nico, you are here? You are with us?
Yes, I'm with
Do you need assistance for the presentation?
I don't know.
Oh, just,
because
let's see.
The cable guy comes while we were in the presentation, when we were in the seminar. He pretended to fix something while it was Daniel's presentation, and the connection just ran away. So now I am connected with the phone.
Okay, so let's go. We only have 25 minutes total.
Sorry, Daniel.
Nico.
Okay, I will go very fast, I think.
Do your best.
Okay.
Okay, we are seeing the presentation.
Maximize this. No, okay. Is it okay? Can you see it?
Yes, it's okay.
Okay.
Yes.
This is a paper that this is a paper that, in a sense, was in a sense, it's a follow-up of Daniel's work. I've been working with this Burton Edward 2010 or something, when we start to talk about this with Daniel. I've been working a lot. In the middle of this, Gabriel in tourism, and so I joined this work that Gabriel was doing with Emiliano. So what was the motivation of this paper? Basically, it's quite interesting following the discussion that I heard, just the last part of the discussion at the end of the Daniel presentation, when I managed to return to the connection. The literature on tourism management is quite interesting at this long list of heuristic at deciding the price of the hotel. It's quite interesting. So indeed, you can see there how the practice of setting prices is not this equilibrium that it is for dynamic for Bellman equation that have exponential states. So you need this oblivion equilibrium to solve. So you can see, if you go into the revenue management literature, how these guys solve the problem with just slightly bit more complex than the heuristic proposal. Definitely, you can see there a full set of heuristics. So you have all these heuristic, but what you don't have is you don't have many studies on what are the consequences on welfare of applying those heuristics. So, and this is somehow the motivation of the paper. So it's what is the consequences on the decision that tourists made about, you know, where to travel, with whom to travel, and how long to stay, how much to spend. So this is like a beginning on trying to work on this. So this is, you have this researchable question, which somehow is what are the consequences of price dynamic on tourist welfare, and I will work on one result. So basically, we have one result, which is the price update rule can generate price increases. Which is, I think, for me, it was quite counterintuitive. I will show you how does it work. Even when resorts compete intensively with each other. And we propose an interpretation of this result in terms of prospect theory behind, you know, prospect theory within the behavioral rule followed by the resort. Another result is social preferences can cause tourists to go to hotels that are not the type that they will prefer if they were alone. So, you know, you might prefer, if you are alone, you might prefer to go to some type of hotel, but given that you have some social preferences interacting with your individual preferences, it might be the case that you end up in an hotel that you don't really like, but you like the people in the hotel. Definitely total welfare can be reduced due to capacity constraint. So okay, I will do what someone suggests me to turn off the video so that the presentation work better. Okay. The literature of Burton Edward model that we have been talking about before. So let me go to the model. In the model, there are N tourists and R resorts. The N tourists can be classified in gamma types. and they are resorts into omega type of resorts. So you have tourists and type of tourists, and you have resorts and type of resorts. Omega and gamma make a non-empty partition. This is of the set of tourists and resorts. So basically you have this non-empty partition. Let me go. So this is the tourist problem. He is trying to, this is the utility that the tourists get as consequences of going to the resort E. So you have this first part of the utility function is the individual preference. So that is the type of hotel that you would like to go, that the tourist would like to go. So this is tau I. So where the tourist I would like to go, if naturally if he will be alone. So this is this function telling you that it's one if the type of resort is the type that you like, and 0 otherwise. So this is the individual preference, and here you have the social preference telling you that MGA is the share of people of type J that are in the hotel E. So if M equal to 1 means that everyone in the hotel is of the same type of people that you like to be with. And M minus G is other types of people that that are there, and so you might have some negative preference to that. So you have positive preference. So this is the crowding effect. You like to be with people like yourself. So just for making clear how this utility function works, what we're saying is that you have individual preferences. So suppose you might like resort in the sun and sun place, or you might like a hotel in the mountain. But this is your individual preferences, and you might have some social preferences. For instance, you would like to be with young people because you're noisy, or you might like to go. So you want to go with your family, with your kids. So you want to be in a hotel where everything is calm. You can sleep well at night. And so in this sense, you have here the social preferences, and you have here the individual preferences. So it might be the case that you end up if you like to be with young people and you like to be in a sun and sun resort, you might end up there, with young people in a place close to the sun, close to the beach. And so this is what this utility function is trying to capture. So the tourist is trying to maximize this. So he's trying to select the hotel that make this utility maximum. The tourists also have an exogenous income. And so the price that he will pay for the hotel has to be lower than that exogenous income every time that he decides to go to the hotel. So we're saying here that somehow it's not that the tourist is not able to pay 1 day or 2 days. What we're saying is that just there is a package. Suppose that there is a week, so there is a package, and everyone is buying this package. And so the price of the package is PE. Okay. So that is the tourist problem. So this is the resort problem. So the resort is trying to maximize the profit. And in order to maximize the profit, he has some constant marginal cost. This is the capacity. So this is the number of packages that the hotel sell, and it has some constraints. So it has to be lower than Q bar J, and the price, of course, has to be greater than the cost. So this is a problem that it's trying to solve the resort. There are some aggregate constraints. The market capacity is given by the sum of all the capacity of the firms. No one in the market is able to, there's no resource that can satisfy all the demand in the market. So this is the Bertrand-Edwards conjecture. There is room for everyone. So the total production, the total number of packages that are in the market are enough for all the tourists. And the total income in the market is greater than the total cost of production. So this is the Bertrand-Edwards conjecture. So you have the demand side and the supply side, and we tried to analyze this on pieces at the very beginning. So we split the model in many parts, and we tried to analyze in separate way. And later on, we put all the things together into an agent-based model. So on the demand side, what you have is it's a couple of propositions. You know, if the parameters are so that this is the individual preference minus the what you want to avoid, which is the social people that you don't want with you. If this is greater than B, then what happens is that full separation by individual preferences on results. So everyone will go to the resort that they will like to go if they will be alone. So this is just for the space of parameters, or having knowledge about the space of parameter. And the proposition 2 is also important because it shows how the social preferences, the intensity of the social preferences might affect your final decision. So remember that B and D are the intensity of the social preference. So if you know, if an M1 in this case is the crowding type, so suppose that the tourists have to decide between two resorts, and one of the resorts is the preferred one, the other one, so one of the resorts is the individual preferred one, and the other is not the individual. So in M1 is the proportion of people like the tourists that are in the resort that they will prefer if they will be individual, and M2 is the proportion of people that are in the resort that they will not go if they will be alone. So what we're saying here is just the highest the intensity of the social preference is the higher the probability that you end up in a resort that you might not prefer if you will be alone. So this is just a proposition for that. And this is a note, just it is not the same than the results that you have in the paper of Brida 2010. Just this is for Gabriel, that these results are not the same that you have in that paper. So this is on the characterization of the demand side. So you have, let me see the time. So you have so now let's try to put in this, so we will take out the social preferences. We will work only with the preferences of the individual. And now we put again the resorts. Here you have, this is exactly the same configuration than the paper that just Daniel mentioned before. So this is a Bertrand-Edwards model. So for a particular configuration, you have a Bertrand-Edwards model here. And we know, as Daniel mentioned before, that we don't have a pure Nash equilibrium for this. So we can characterize a part of this model, but it's hard to do it. So we need to move into some learning structures in order to make a better characterization of the model. So I'm running out of time. Let me see how. Okay, so we implement this agent-based model. that you have the timing that we can divide it in 3 stages. In the first stage, the tourists get the income, the exogenous income. So we are not dealing with the sources of income. In the second stage, the resort update their price, and they will update the price following exactly the same rule that Daniel proposed as the better rule that characterized the behavior of the subjects in the experiment. In the third stage, tourists decide to go to different resorts according to the learning rule that they have. I'm really sorry, but I will go fast on this. Here is the Daniel rule for updating. The unique differences is that here mu is the utilization level of the resort. So we put this parameter just for dealing with the parameter that's important in the literature of tourism, but it's exactly the same rule. And what we get is, so here is a simulation. Remember, you have this lambda plus and lambda minus, which are the intensity that the resort used to update their price toward, to increase the price or to reduce the price. And what we get is that, if the lambda plus is greater than lambda minus, this is price, the average price in the economy. This is just for with 20 tourists and 2 resorts. So the average price will goes up. While if lambda plus is less than lambda minus, what you will have is that the price will go down toward close to marginal cost. The line in red here is the market equilibrium defined by Daniel. So what you have here is that if lambda plus is greater than lambda minus, what you will have is that the prices will goes up until they basically they take all the budget available in the economy. Okay, that's a good number. So this is one of the features that we found in the model. And so this is somehow counterintuitive, that even though these 2 resorts are competing between them, so this is an oligopoly where they are competing between them, so the price goes up instead of going down. So why is that? So we follow here, we try to explain how that mechanism works. So you have here 2 firms competing. One firm is the firm's X, the other is the firm's O. So they follow the behavioral rule with lambda equal 3, lambda plus equal 3 and lambda minus equal 1. So suppose that they start with the price for Px 2 and for P0 3. So here you have the price, and X is the price of firm 2. The firm X has the price 2, and the firm 0 or the firm's O has the price 3. So in this case, firm X he sell everything, and firm 0 he doesn't sell the whole thing because he there's capacity constraints. So X sell everything. O he doesn't sell everything because he has a higher price, so he only take the residual demand, and the residual demand is not enough to satisfy all its capacity. So what happened in the second period? In the second period, what happened is that this is following the Daniel rule. So firm X will increase the price because you will apply the lambda plus, and firm O will reduce the price, so -1. And so this is the configuration that we will have in the second period. So in this case, firm O will collect all, so will satisfy all his production, and firm X will have some excess of capacity to use. So what will happen in the third period, it will be that, you know, firm X will reduce the price in 1 and firm O will increase the price in 3. So now X sell everything, O no. So this rule keep applying, and what you can see is that even though they are competing, the price, the average price goes up. So this is the mechanism how these things work. I think it is somehow counterintuitive. And what we have done later on is that to make a greater characterization of that mechanism, not only for 2 firms, but for our firms. And it works again.
Nico, we have three minutes.
Okay. Okay. So, and what we have tried to do is to interpret that mechanism in terms of prospect theory, saying that, you know, prospect theory is telling you that people is adverse to losses, and they are more prone to take risky choices. So what we're saying is that, you know, this prospect theory behavior is saying that you will have a lambda plus greater than the lambda minus. So the prospect theory mechanism is the one that it is producing this, it might produce this sort of behavior. Okay. Okay, so just a couple of additional results, but for the sake of time, I stop here. Thank you. Gabriel?
Yes, thank you very much, Nico. So we have time for Eric for some comments.
Yes.
Quickly, because
yes.
they cut without. Okay.
Yes, thank you very much, Nico, for your very interesting presentation. I will go very fast. You are reading my presentation, huh?
Yes.
Okay, I think that in my comments, the most important, for me, the most important comment is that I really like that you combine tourism economics with game theory and computational modeling, because I think that the economic theory has bypassed the importance of tourism and has failed in recognizing the complexities behind the tourism as an economic good. And I also like that this paper has some insights in the post-corona world, particularly, for instance, one might wonder what is the impact of preference for crowding over the social distancing. And well, I have one question about if you have empirical evidence of this kind of pricing. That is my first question. The second question is if in some cases you use an n equal to 50 tourists, and in some cases we have n equal to 20. So are the results the same with any size of n, or it may be a critical point that modifies the outcome? A third question is if there is a theoretical or empirical justification for the parameters values. And the third one is what happens that lambda plus is greater than lambda minus. So what is the market structure behind this condition? And that's all. I'm finished.
Okay, great. Thank you, Eric. Are you going fast?
Thank you.
I was very efficient. Fast. Very fast.
Very efficient. Very German.
The first question, I just give it to Daniel. So, you know, what we are using is just the results of the Daniel paper in terms of that is the heuristic that somehow capture well the decision made by subject in the laboratory. So that is the rationality of using that rule. So that is related to your first question. The second question is there is some sensitivity related to scale, but it's not very important. But I think that we still have to run a couple of simulations to figure out that more consistently. The there is no empirical justification for the value of lambda. And I don't have a good idea about, right now, I don't have a good idea about how to do that. It might be a challenge. We have been talking about looking at the data. It turned out to be very hard to get price data coming from hotel or resorts. Basically, I mean, for free. If you are ready to pay, you can get it, but so that makes us hard to get the data in order to somehow approximate lambda. Why happens that lambda plus is greater than lambda minus? Well, that was what we were trying to explain, that, you know, that's kind of counterintuitive result in terms of if lambda plus is greater than lambda minus, what you have is like the price goes up, even though you have competition between the resorts. So this is that mechanism that I tried to explain before. You know, how does it work? That in a sense, it's strange because it's like you are going through a stair. So you raise the price and we compete, but later on I raise the price a little bit more and we keep competing, but and so it's like a stair. And that stair works only when lambda plus is greater than lambda minus, just in the case of two firms. If you have more firms, the rules are more complicated. But so that is how does it work.
Thanks, Nicolás.
Okay, thank you, Eric. Thank you for your comments.
It seems that we still have time, so if somebody wants to ask something more, or Daniel, if you want to answer the question of Eric.
Well, no. What we did is we gathered the data of the experiments and simply took it from there. I mean, so there's no theory behind that. There's no theory behind these parameters. The only thing that I may suggest is that as the play goes on, you see that people start with large numbers, with large adjustments, as if there was some search on a wider space. And as the experiment follows, then you see the parameters coming down. The people become a little bit more conservative. But that's simply an experimental observation, nothing more than that.
And Daniel, sorry, can I ask you a question?
Yeah.
I don't remember. Manage, like, in a sense, is the question, one of the questions of Eric. Did you manage to get what is the parameter of the lambdas in the experiment? What is the value of the lambdas?
Well, yes. I mean, there is some reference in the paper that you have the absolute value coming down as the play goes on. But people start very actively changing their prices and looking for high profits. And then as the experiment continues, it sort of organizes, and sometimes you get these very small adjustments, as if people were scared not to sell, so to speak, and they didn't want to rock the system. So, and then you get some excursions when the thing becomes too dull.
Yes.
Someone rocks the boat, so to speak. So you have this sort of oscillation between quiet times and times of strong competition. But that's what we observe. It's not something that has been theorized about. Okay.
Yes, thank you.
I'm sorry, but you know, Flaminio asked us to cut the session because there is a session of the journal, just the editors meet authors, referees, and readers. So thank you very much to everybody to attend, to present, for the presentations, for attending the session. It was very nice, very good presentation, very good comments. So see you next time.
Okay, thank you.
Thank you, Gabriel.
Thank you.
Thank you, everyone. Thank you.
Thank you.
Saludo, Nico.
Chao, Gabriel. Nos vemos.
Abrazo.
Gracias.
Sí, espera, que viene Cristina, te saludo.